Hi, John Valvano here, and in this last video of the schematic, we're going to make sure everything is right before we switch into the PCB. So it's best not to have doing a flip-flop where you do a little bit of schematic and do a little bit of PCB, a little bit of schematic, a little bit of PCB, because that will take you a long time. So what we're going to do here is first check. You notice I opened up the design manager over here, and let's start with the nets. Okay, so the nets are things we want to make sure that they're perfect. Okay, so I'll zoom this up so you can see. And so if you view the nets and then start clicking on the nets, it'll show you where the nets is. Now this is a big one. This is all the grounds. Okay, so it's showing you in the circuit where all the grounds are. Okay, so one by one, I'm going to check this. This is where my 3.3 is going. Okay, this is some of these don't go anywhere. Well, this is the LCD reset. Okay, so the LCD data command. There's port B in my DAC. There's another port B in my DAC. There's another pin on my display. Another pin on my display. Display. There's PB2, PB3, PB4, PB5. Okay. Now you notice PB6 doesn't go anywhere. Okay, so this actually won't show up on the PCB at all, even though there's a net. Okay, because it's not connected to anything. It has to be connected between two parts for it to be a trace. Okay, but we don't mind. We're checking it, right? That means that's an unused pin. That's PB7, an unused pin. Again, 5 volts doesn't go anywhere because this here is it's just a symbol. It's not a part. Okay, so again, there'll be no 5-volt traces on your PCB. The reset line doesn't go anywhere. These 5 pins on the launch pad don't go anywhere. On your PCB, obviously they're on the launch pad. The blue one, the red one, the switch on the launch pad, a PD7, Paul David 7, goes into the LCD to turn on the secure digital card. Paul David 6 is unused. Paul David 3 is the scope, and you can see it's connected between the center pin of the 3-pin header to the port. There's PD3, and you can see it goes 3 places to the slide pot, to the 3-pin header, and the microcontroller. You see, you're going through this and make sure everything makes sense. Just like when you're wiring it, does it make sense? PD1, PD0. Again, that launch pad don't matter. PE5 is unused. PE4 turned out to be unused. PE3 is one of the switches. PE2, another switch. PE1, another switch. PE0, the last switch. And the 4 pins on, 2 pins, PC7 and 6 are unused, but PC5 and 4 are going to go to the UART for Lab 9 for that other 3-pin header. Okay. There's my DAC out. It goes a bunch of places, right? It goes to the actual DAC. It goes to the speaker. And so, yeah, zoom in here, make sure everything's right. You can see it goes to the speaker, to the audio jack, and to that 3-pin header. This is the symbol that went between the resistor and the green LED, the red LED, in between 2 resistors on my DAC, and I'm done. Okay, so that was nets. Next, I want to look at the parts. Okay, again, to make sure I haven't made any mistakes. So I'm going to look at the parts. And I'm going to make this bigger this time. Okay. Now, some of these parts, as we've been talking, aren't parts at all. Okay. That's just the beautiful frame. That's another frame. That's just a ground symbol. It's not an actual part. That's a ground symbol. But there's a part. There's switch 1. There's switch 2. Another ground. Switch 3. Switch 4. This is a test point. You can see its value is TP loop. That'll show up on the PCB. That'll be a little wire we can loop on there to hook up a voltmeter or whatever. There's another frame. Now these next parts are the microcontroller itself, sort of ensemble. There's 6 or so of these parts, which together, that's B, there's C, there's D, there's E, there's F, and then there's a bunch of leftover things for the power and ground. There's my LCD. There's my external speaker that I can solder onto the board. Another ground pin. Again, another label that's not really a part. That one's not really a part. That's not a part. But here are my 10K resistors for the switches, R1, R2, R3, R4, and now we got a bunch of resistors inside the DAC, R5, R6, R7, R8, R9, R10. Notice there's no R11. Okay, does that bother you? I don't know, it doesn't bother me. There's an R12, because I threw some away. There's no R13. And then there's R14, there's R15, there's LED1, but there's no LED2 because I obviously threw the yellow one away. Okay, but there's LED3. That's one of those ground lips. And there's my slide. Okay, there's 2 more resistors here in the DAC, R20, R21, and R22 was the slide pot. There's my jack. That's the audio jack. That's the ground. This is an actual part that we can hook clip our ground clip on when we use the voltmeter. There's the analog input from Lab 8. Again, we can hook our voltmeter up to that pin. There's another test point that we can hook up. There's the 3-pin header. There's another 3-pin header. Just a ground symbol, a power symbol, and a last ground symbol, and I'm done. Okay, so there we are. Now I'm ready to go. So let's switch. Let's just do what we just did in the schematic on the PCB. Okay, so we'll talk about the PCB in the next section of videos, but let's make a little bit of a preview into the PCB. This is the other phase of the design, which is what it looks like physically when it's soldered together. And we'll talk about this in more detail, but let's just check our devices. Now, what I want you to do is not do any changes to the PCB until we form the groups with 2, 3, 4, or 5 people per group. And that way you don't have to, we will make a single PCB design, get 5 copies of the PCB, okay, for that group. Okay, so I'm going to look at devices here. Okay. And so I'm going to go into this symbol here, and I'm just going to look at the devices. Okay. This is what I mean by a test point. A test point is 2 holes, and you're going to solder a loopy solid wire that you clipped off from the end of a resistor. There's a test point. There's another test point. They all look the same. Test point. This is the 3-pin male header for the connecting up Texas either to the DAC or the slide pot. There's our audio jack. This is the 3-pin male header for Lab 9. And then we got a couple of LEDs. That's what it's going to look like on the PCB. 2 holes that we soldered the LED into, 5 millimeters apart. That's how big it is. There's the green one. And then these are the resistors. They're all the same size, but you notice on the silk screen, the white stuff, it's going to tell you the R number and the resistor value. That'll help you solder it. Okay, so we're going to make sure we have, all the resistors the right size. There's R1, R2, R3, R4, R5, R6, R7, 8, 9. There was still no 11, 12, no 13, 14, 15. R20, R21, and then R22 is a weird one. That's the slide pot. Okay. There's the 2 wires I'm going to hook my speaker up to. There's my 4 switches. Okay, so we're going to solder them down into those 4 holes. 1, 2, 3, 4. The booster pack is this big 40-pin header that's going to be male headers that we plug into. And there's my display. Okay, so all right, so now your job now is to finish your schematic and send it to me for review. All right, enjoy.